Lesson 2.3, Video 4. Now, there's a little bit more work to be done to create an elimination situation. Now again, I have to fix this. This is solving by elimination. Now, they have multiplied one of the equations by -10. So if we look closely, we'll see why they did it. As is, x plus y equals -5 isn't good enough. But they notice that they can cancel the y's if the y in the second equation had a value of -10. So they multiplied the whole thing, the whole equation, by -10, which would create a new system of equations, but now it's -10x for the second one, minus 10y equals positive 50. Notice now that the y's cancel, and we have negative 3x equals positive 21. Divide both sides by -3, and x equals -7. Now this number here is something you're going to get good at figuring out what that number would be that allows you to do what we just did. But don't forget, we're looking for a coordinate. Our x is -7. We have to plug that number in to one of these two equations. Okay, I'm going to choose the first one, which gives us 7 times -7 plus 10y equals -29. And we have -49 plus 10y equals -29. If we add 49 to both sides, we get 20. Divide both sides by 10, and we get 2 for y. If we look at the next question, they've already given us our number, so we'll distribute it, and we get a new system of equations. Now it's going to be a -6x plus 15y. Notice the y's are opposite values now, equals 6. But notice what happens. Our x's and y's all disappear. We even have a 0 on the other side. And this brings up a situation where if you cancel all variables and you end up with just numbers, but it is a true statement, then it is called an infinite number of solutions, or many. If you end up with a solution like this where it turns up to be 0 equals 2, then we would say no solution. So a special case scenario there. Here represents parallel lines, and here represents, if we graphed the lines, we'd have the same line on top of each other. Here we have no solution because they're parallel. And this ends lesson 2.3, video 4.